So in this lesson, we're going to talk about properties of logarithms. So by the end of this video, you should be able to relate the properties of exponents to their corresponding property of logarithms. Here's the standard that we are going to be using. And notice it really doesn't say anything about logarithms, but it's talking about properties of exponents, and exponential expressions are inverses of logarithmic expressions. Okay, so just as a reminder, when we're going ahead and each of these has a corresponding property. So if I have an exponential property, there's one that goes with logarithms. So the product property says if I have something like x to the fifth times x squared, if the bases are the same, I keep the base and I add the exponents. Well, remember, logarithmic expressions basically are expressions that are giving us the products with the base in the logarithm, okay? And it's a manipulation of the exponents because the answer to a logarithmic expression is the exponent of the base. That means it's telling us that if I am multiplying, so let's look at that property as a logarithm. So here's what it says. It says, if you are taking, so this is your product, okay, you can write it as the sum of the exponents. And remember, the logarithm is so here's what it says. It says that if you go ahead and you're taking the log of a product, that you can write it as two separate logarithms. So in other words, two separate exponents that are being added together. So let's try it. Okay, so both of these have the same base, which is 2, even though you can't see the 2. So I'm going to go ahead and I'm going to do what we call condense. Condense means take it from two different logarithms to one single logarithm. So I'm working this way. So I'm going to rewrite it, and it says I'm adding the exponents, which means I can rewrite them as the product of the two expressions. Okay, let's try another one. So on this one, I'm actually going to work it out and show you how this one actually makes things useful for us. So then remember, the hidden base here is 10, but I don't need to write it because remember, it's a common log. So I don't know what the log of 25 of the base of 10 is, nor do I know 10 to what power makes 4. But if I go ahead and I use my properties, because I'm adding two logarithms with a common base, I can rewrite it as the product. So I'm going again this direction. And that gives me the log of 100. But remember, that base is 10. So 10 to what power makes 100? It gives me 2. So this way, I could not figure out what the answer was. But when I condense it, it allows me to see that the product is 100. Therefore, the exponent had to be 2. Okay, and we're still condensing, so we're going from, when I see multiple logarithms, that usually tells me what I'm going to be doing. Okay, so I see the bases are the same, so I can use my property. So it says log base 4. Remember, if I'm adding the logarithms, I multiply the products. 2 times 4 is going to be 8. X times x squared is x cubed. Now this one, it just doesn't help us, but we've shortened up a little bit. Okay, so just like you can condense, you can also expand. So sometimes it's hard to see how you're going to expand it, so here we are at number 4. So what this is saying is, can I break the 6 up into something that is a product of two numbers? Well, yeah, because 2 times 3 makes 6. So if I rewrite this with common log of 2 plus the common log of 3. Same thing over here on number 5. What's two numbers that multiply to 45? Could be any two numbers, but let's say I decided to do it as 9 and 5. Then I would write this as log base 7 of 9 plus log base 7 of 5. And finally, looking at number 6, what are my two factors here? 5 and x. So I would write this as log base 2 of 5 plus log base 2 of x. Okay, so the quotient property for exponents says that if the bases are the same and I'm dividing, I take my exponents and I subtract them. So with logarithmic expressions, it kind of looks the same. It says if I'm taking the log of a quotient, then I rewrite it as log of the numerator minus the log of the denominator. Okay, so let's go ahead and condense. We're not going to do all of these this time. So let's look at number 8. So it's log base 2, because my bases are the same, and that's why I can actually use this property. Only the bases are the same, don't forget. Numerator over denominator. Well, if I go 15 divided by 15, I get 1. My base is still 2. Well, 2 to what power makes 1? That would be 0. I'm going to do the last one on that, number 9 also. So what's my common base? 4. Since it's subtraction and the bases are the same, I'm going to write it as first term minus or divided by second term. And remember, a property of exponents, say I subtract the exponents, which would give me log base 4 x to the 7th. Okay, and again, just like we can expand, we can condense. So let's say we're doing number 11. So I have log base 5 of the numerator minus log base 5 of the denominator. And what's log base 5 of 1? Well, that would make 0, because 5 to what power makes 1? 0. So if I do 0 minus log base 5 of 3, I end up with just the opposite of the log base 5 of 3. Okay, final property that we're going to relate to logarithms is the power property. So remember, the power property with exponents says that if you take an exponential expression and raise that expression to a power, we multiply. Now this one looks a little weird, but here's what it actually is saying. It says that because this is really an exponent, that we can take that exponent and it becomes a coefficient. So let's use it. Okay, so condense means to not have anything in front or after the log expression. So I'm going to take my coefficient and it becomes the exponent. So log base 4 of 2 to the 5th, which is log base 4 of 32. And this one would be log base 2 of x to the 7th. And this one would be log of 8 to the 1/3. The 8 to the 1/3 is the cube root of 8. Now remember, the cube root of 8 is 2. So that would give me log base 10 of 2. Okay, and we can also go ahead and expand with this property, and it says basically any exponents become coefficients. 7 log base 2 of 8. Well, guess what? 2 to what power makes 8? Oops, I forgot to put log. So what is log base 2 of 8? This is equals to 3. So that means I get 7 times 3, which is 21. Okay, so on this one, number 17, this exponent, remember, is going to become a coefficient. But even though there's something there already, we can deal with it. Our base is 10. Okay, so I got to distribute. 3x minus 3. I'm going to put that in parentheses because the whole thing is the coefficient, times log base 10 of 4. Okay, so for expanding, which means we don't want it to just be a logarithm all by itself. So I can't do that because I don't have an exponent here, but I can use what I know about exponents and fractions and rational and all that stuff. Because w with a square root sign is the same as w to the 1/2. So what I really have is log base 7 of w to the 1/2, and the exponent becomes the coefficient. Okay, and we're going to go ahead and we're going to do one more thing on this because sometimes you might see this written. So when you multiply something by 1/2, it's the equivalent in math of dividing by 2. And because of that, 1/2 times the log base 7 of w is the same as taking that logarithm and dividing it by 2. Notice that the division sign goes the whole entire way because this is different than the quotient property. Okay, and that's it for properties.